Hello, my name is Ben Parmer, and this is my project for week 3. So this is very similar to what I did for the week 2 project. I decided to stick with the exact same shape, which was a W30 by 292 shape. And this isn't really that important for this week, but I just wanted to show you where I got the actual dimensions from, and this is directly from the steel manual right here, these dimensions. So to define the bottom flange, I did it a little bit different than I did from last time. Last time I made this shape, I put the origin at the bottom left corner of the entire shape. But this time for the scalar field and the vector field to actually work out the way I wanted it to, the origin had to be in the exact center of this beam. So that's why you see in the x1 direction there's a negative 15 and a positive 15, because that puts the origin at the center of the beam. And that's the length, which is 30 feet. Sorry, that's incorrect, but 30 feet is what I decided to go with this time, so you could actually see the deflection that I do later on. But the original 10-foot length, it just wasn't enough to actually show the deflection. And then here is the width of the bottom flange from negative to positive. So that again puts the origin at the center. And this is in feet right here. And then the thickness of that bottom flange. So 30 feet in length. I still did the 5 grid points in each dimension. And then, of course, since each shape is a cube or a rectangular cube, it has 6 faces and 12 edges. So here's the web defined again, same length obviously, so it's negative 15 to 15, and then here's the dimensions for the thickness of the web and then the actual height of just the web. And then the top flange, same length, and then it's the same as the bottom flange, it's just moved up to sit on top of that web. And here's what my beam looked like in the plot parameterization window. So this just kind of shows you the size comparison of all the bodies put together. So here's the beam itself and then a cross section of the beam. And as you can see, I had the 0 and 0 right here, so that puts the origin right in the center of the beam. So moving on to what this project was actually about, which was the scalar, vector, and tensor fields. There was no need to change the tensor fields, so that all stayed the same from the example that we did in class. For the scalar field, though, since it is a cube, I found that the best looking scalar field was x1 times x2 times x3, and that actually gave me what I wanted to see. For the vector field, I only wanted to do deflection in the x3 direction, which is down, and it kind of simulates if you put a load on this beam and it started to deflect. I couldn't get it to deflect in a curve, but I did my best to get it to deflect or just like look like it was being pushed down basically in the vector field. But I wanted it to move down just a little bit, and since x3 can be negative or positive, I squared that and then multiplied it by a very small value to show little deflection, and that's why it's a negative, is because I want it to go down. So here's the scalar field for the entire beam, and then the vector field, and as you can see, all those vectors are pointing down to show downward deflection. And then here's the actual deflection. It's very slight because of that 0.02, but it is deflecting down just a little bit. The whole beam is being moved down by that value. And then here is my tensor field, which is equal on each side. And then the parameterization equations, which I worked on last week, these remain the same. These are just basically the dimensions for the beam with respect to S1, S2, and S3. And then the volume itself was 5.93. And then, like I said, with that deflection equation, here it is for 0.002 times x3 squared, and that gives you a positive regardless. But add a negative here, and it's in the downward direction. But that's all I have. Thank you so much.